Hello, in this video we're going to take a look at using Cramer's rule to solve systems of linear equations. So for Cramer's rule, we are going to set up, here we have two equations, two variables, so we're going to set up a total of 3 determinants. And what we're going to be looking at for our determinants, first thing we want to do is get each of our equations in that general form where we have all of our x's, our y's, and equals and constants lined up. And then the first matrix, we're going to call that the D matrix, is going to be just the coefficients on the left-hand side of the equal sign. So that's going to be, in this case, we've got x plus y equals 7, and x minus y equals 5. So we're going to get 1x, 1y, 1x, negative 1y. So that's going to be our D matrix. Now to find the value of our x coordinate, that's going to be in the denominator. So 1, 1, 1, negative 1 is going to be our denominator. In the numerator, what we're going to do is we are going to replace our x coefficients with the coefficients in the constant spot. So instead of the 1 and 1 that we have in that D matrix, we're going to replace that with our 7 and our 5. The rest of it is going to be exactly the same. To find our y values, we're going to do the same thing, but we're going to now replace the y values in that D matrix. So instead of, we still have the same denominator, 1, 1, 1, negative 1, but we're going to have our constants in our replacing the y coordinates to find our y value. Our x coordinates are going to stay the same as they are in the D. And then we can just simplify those. Let's see, 7 times negative 1 is negative 7, minus 5 times 1 is 5. In the denominator, we're going to get 1 times negative 1, or negative 1, minus 1 times 1, which is 1. So that's going to be a negative 12 over a negative 2, which gives us 6 for our x coordinate. For our y coordinate, we're going to get 5 minus 7 over that same thing we just got, negative 2 in the denominator. So 5 minus 7 is going to be a negative 2 divided by negative 2 is 1. So we do get the 0.61. All right, so let's do another one of those. Here we have the system of equations 4x equals 16 and 5x plus 5y equals 0. So again, we want to get that D matrix. In our D matrix, we've got to have something for x and y, kind of like synthetic division. We have to have all of our coefficients represented. In this first equation, we don't have any y, so we're going to think of that as plus 0y there. So we get 4, 0, 5, 5. That's going to be the denominator on both our x and our y. So 4, 0, 5, 5, and 4, 0, 5, 5. In our numerator, remember for our x value, we are going to replace our x coordinates with, instead of doing 4 and 5, we're going to use 16 and 0 because those are the constants that we have. Our y coordinates are going to stay the same, so these will always come from, be the same thing that we have on our D matrix there at the bottom. For our y matrix, we're going to have the same x values, but we're going to replace the y values with our constants. Instead of those y coefficients, we're going to have the constants. All right, so now if we find this determinant, 16 times 5 is 80 minus 0. In the denominator, we get 4 times 5 is 20 minus 5 times 0 is 0. So we get 80 over 20, which is 4. And then for our y value, 4 times 0 is 0, minus 5 times 16. So we get 0 minus 16 here. So we're going to get or 0 minus 80. And then we still get the 20 that we got in the denominator the first time. And so here we get a negative 4. All right, now let's look at a 3 by 3 system. Same basic idea. First thing we want to do is line up our x, our y's. Now we have z's as well, but x, y, z's, equals, and constants are all going to be lined up. Our D matrix is going to be just the coefficients from the left side of the matrix, or left side of our system. So we get 1, 5, negative 1, because our coefficients are 1, 5, and negative 1. And then 1, negative 5, 1. Negative 4, 5, negative 4. So that's going to be our denominator on our x, our y, and our z. And this one we're going to go ahead and use our calculator to evaluate those determinants. That should be a negative 5, 1, negative 4, 5, negative 4. So our denominator is going to be the D matrix on all of those. And then just like we did on the other one, to find our x value, we are going to copy and paste this matrix in the numerator, but instead of using the x coordinates, we're going to replace them with our constants. So our first column is going to be those constant values. Everything else is going to stay the same. So we're still going to get 5, negative 5, 5, and negative 1, 1, negative 4. To find our y coordinate, we are going to, our x values are going to be the same as the denominator, but instead of our y values from the denominator, we're going to have the constants, and I said that and then I started writing the same ones. We're going to get negative 2, 2, and negative 2. Our x values are going to stay the same. And then same thing for the z's. Now we're just going to replace our z coefficients with the constant. So our x and our y are going to be the same as below. The only thing that's going to change is that now our z's are going to be the constant, negative 2, 2, and negative 2. All right, let's go ahead and use a calculator to find these determinants. So we're going to do second matrix, and then get to the math menu. DET is what we're looking for, so that determinant is the first thing. We get this by going second and then matrix, and then we want to find the determinant of the matrix, so we're going to do alpha zoom. This matrix is 3 by 3, 3 rows, 3 columns. All right, so we're going to get negative 2, 5, negative 1, 2, negative 5, 1, negative 2, 5, negative 4. This is going to be our first numerator. That's going to be our x numerator, and we do get 0. So it doesn't really matter what we get on the bottom. We get 0 there. That x value is going to be 0. We can do second, enter, and just go in and change. Let's go ahead. We'll go ahead. We have to find the determinant of that denominator anyway. And so that's going to be 1, 1, negative 4 is our D matrix. So this is the determinant on the bottom. And we get 30. So we know that all of these are going to be 30 in the bottom. And then with the second enter, we can go in and change the y coordinates. So we've got -2, 2, and -2. So this is going to be the numerator on the y. That is -12. And then our last one, I'm going to go ahead and copy this D that we did up here and then just go in and change those z values to -2, 2, and -2, and we get 0 on that one as well. So our x coordinate is going to be 0. Our y coordinate, that's going to reduce, let's see, 6 goes into both of them. 6 goes into 12 2 times and into 35 times. And then for our z, we get 0 on that one as well. So this, as an ordered triple, would be the point x equals 0, y equal -2/5, z equals 0. All right, I'll see you guys next time.